solutions. The video just cut, didn't it? I was worried about that. That's alright. This is video 3 now. Start this one right where the last one left off. R squared equals 16. So we just talked about how one way to fix this problem with arctan giving you an angle in the wrong quadrant is you can add pi to that. That'll push it back into the right quadrant. If you're in quadrant 2, because x is negative and y is positive, it means you have a negative tangent value. Arctan will put you in the 4th quadrant. Add pi to that, it'll put you in the 2nd. If your xy point is in quadrant 3, it means that they're both negative. Your tangent value should be positive. Arctan will give you a 1st quadrant angle. You can add pi to that, and it'll drop it down into the 3rd quadrant. Or it'll push it over into the 3rd quadrant, I should say. Adding pi is one way to do this. The other way to do this is, we've talked a lot about how this, as an equation, has 2 solutions. R equals 4 is the principal square root for this. R equals negative 4 is another solution to this problem. In our first video, we talked about how sometimes you'd get distances that were negative R values, and that just means that whatever direction you're pointing in, you move backwards. We can do that too. If the homework can give us R values that are negative, we can give it R values that are negative. Turnabout's fair play. So these are the 2 options you have to fix this. You can only do one of them at a time. So I'm going to erase this so I can write some correct answers on the board. R equals 4, theta equals negative pi over 3 is incorrect. That pair is in the wrong quadrant from what we want. So it's not going to work. One way to write this correct answer, if we choose to flip an R, is we could say negative 4 is the radius, negative pi over 3 is our angle. So if we change the radius to negative, that means we can keep the original angle, and there's no problem there. Or, if we add pi to this and get ourselves an angle of 2 pi over 3, then we can keep the original radius as 4. So you have to do one of these modifications for this particular problem, but not both. These problems get extremely tricky. You can't just follow an algorithm and expect to get a correct answer every single time. You can definitely start with some algorithmic thoughts, but at some point when you're doing these problems, you have to stop and just engage in some very real critical thinking about the position of the point you started with and the position of the point that the algorithms are giving you, and whether or not that's correct, and if it's not correct, what you need to do to fix it. That's all I have for this video, so I'm going to sign out. Do some homework, ask me some questions.